axis, the problem with this lesson is the background. You don't have it. This is my only slide of notes. The problem with this slide of notes is it will make no sense to you because I don't think you've done any matrixy work. Okay? So I've got to do some basics with you, make sure you understand what's going on. Okay? All right. Couple things we want to do. A translation vector. Let me actually get a marker here. I just freehand this. This translation vector 1, 2, 3, 4, 1, 2 is the ordered pair 4, 2. Okay? You've done that. I know you've done that work. All right? What you probably have not looked at that as a matrix. In matrix form, it would look like this, and we would say 4, 2 this way. Okay? And if I took a triangle that's over here, and I have negative 6, negative 2, and negative 8, negative 6, and negative 4, negative 7 are my 3 points. Okay? Just creating this triangle. And I want to translate it with this vector. But what that means is I would move every point this far in this direction, right? 4 units to the right and 2 units up. Well, if I wanted to use a matrix to do that, then I would take these 3 points and I'd put them in matrix form. And so it would be negative 6, negative 2, negative 8, negative 6, and negative 4, negative 7, with the x's on top and the y's on the bottom. Okay? And when we translate, what do we do to the points? If I move the x 4 units to the right, what would I do with those two numbers? Would I multiply them? I would add them, right? I would add those two numbers together. So a translation vector means I have to add them. And so to write my translation vector, and this is something you probably haven't had a lot of, to add matrices, you have to have identical dimensions. So this matrix is 2 rows and 3 columns, so it's a 2 by 3. It's always rows by columns. Rows by columns. Okay? So that's a 2 by 3. So this would have to be a 2 by 3. And so I need those. Okay? Need those numbers. And what am I adding to every one of my x's? A 4. So that means up here I have to have a 4 in each one of these. And what am I adding to every one of my y's? A 2. I was thinking it's negative 2, but it's not. A 2 to each one. So my translation matrix that I would add to my matrix that represents my figure, in this case a triangle, would have to be 4's across the top and 2's across the bottom. So to translate using matrices, I just add them, and the matrix would look just like this. Okay? Well, that's simple 2-dimensional. Today, we're doing that in a 3-dimensional. We're doing more than that, but one of the things is. And so, if I look at a 3-dimensional graph, looks something like this. And remember, the positive x is out here. The positive y is over here. And the positive z is up here. So that makes this the negative x, the negative negative y, and the negative z. Okay? Remember that? I think we just talked about that not long ago, right? Am I losing my mind? Leave it here in a different class. No. Okay. And Mrs. Mills had the string strung across the classroom to break it up into three-dimensional graph. And so, anyway, that's what it looks like. Now, if I took this shape, let's get a marker. Yeah. Luckily on the recording you can't see how I'm stumbling through this quite so much. Alright, so if I took this box, okay, this box of cereal must be Honey Cheerios. If I took this box and I wanted to translate the whole box, okay, well, first thing I need to do is find all of my coordinates. And sometimes that's really easy, and sometimes that's really hard. With a box, it's a little easier because lines are parallel. And lengths of sides are equal. Like this is equal to this, equal to this, equal to this. And these are all equal. And then these are all equal. Okay? So that helps us. Alright? So if this point is 0, because it didn't come out at all, 2, because it went 2 this way, and 0 because it didn't go up at all, right? Right on the y-axis. So it's x and z coordinates are 0, and its y is 2. Okay? That's, yeah, y is 2. Now if I took this one, it's 0x, 0y, and let's call it 6 on the z. Okay? If I took this one back here, and we'll call that, that's on the x, let's call it negative 7. And then 0y and 0z. Those three are all we need. We probably could figure out the rest of them, couldn't we? Right. Okay. Let's do that and make a matrix instead of writing them all up there. Let's make a matrix out of that. How many points do I have? Louder, please. I've identified 3, but how many am I figured? 8. Okay? And so let's label this A, B, C, D, and then E, F, G, and that one back there we'll call H. Alright, so we'll go A, B, C, D, E, F, G, H. Hopefully that's 8 points. Yeah, okay. So A, what did we say A was? So we said X and Y is here, so then it makes sense Z would be underneath it, right? Okay. Now we don't have B. So help me figure out what's B.
0, 2, 6.
Yeah, 0 because it didn't come this way at all, or this way. And it went this way 2, and then up 6. So 0, 2, 6. Okay? Alright, now what's C?
0, 2, 0.
Yeah, we already identified that one, didn't we? 0, 2, 0. Okay, someone other than Max this time. D is a really hard one.
0, 0, 0.
Yeah, way to go, Alexis. D is at the origin, right? So 0, 0, 0. E, someone new. Let's get a new person each time. E is not written very well, but it's this one up here.
7, 2, and 0.
-7, 2,
And 6.
and then 6. Good. Because we went back 7, right 2, and up 6 to get there, right? Okay, good. Now, we did F. G. One of the Megans. I'll let you fight over it. Nice. -7, 2, and 0. She went back 7, right 2, and not up or down at all. Okay? And then H. Maggie, what's H? Ah, nice job, Megan. You're really good. Now, if we use that same translation vector we used just a moment ago, oh, I'm sorry, we can't because it was two-dimensional. Let's throw a new one in here. Let's do this one. And let's put a point on there. One, 0. 5, 4, 3, 2, 1, 0. Okay, so we'll go -1, x is back 1, and then right. Come on in, you're welcome. So if I go left 6, what is that number? -6, good. And then I'll let you guess. How far up I go? 2? You just went up this 2 here, right? So that's a positive 2. Do you agree? All right. So I want to write the matrix now that represents that translation of -1, -6, and 2. That's all right. Take a minute to think about it. I'll pause this so we're not recording. You guys, sorry you're at home. You missed a great conversation. Say it one more time, nice and loud, Alexis.
You add off the -1s to the x's, and you add the -6s to the y's, and you add the 2's to the z's.
Right. And so probably all of us are pretty sharp at this after we've done one, and we can say, do I really have to write all that down? The reality is no, you probably don't. Okay? But if on the test I say use a translation matrix to do this, then I really want you to just show me that you understand what that looks like. So write that down once. So are there going to be lots of these on the test? No, there would at most be one. Okay, I would just want you to show me once that you understand what it looks like, and then just give me the answer. And so let's make a little room here. My answer is going to be
-1, -1, -1.
-1, -1, -1,
-1, -1.
-1,
4 -8.
4 -8s. Okay? My loops didn't come together. 4 -8s. Okay, someone other than Max now.
-6,
-6, -4, -4, okay? And then someone other than those two. 8, 2, 2. Did you say 2, 2 again? Oh, my ears are slow.
8,
8, 8, and then 2, 2 again. Okay, good. And so that's what our matrix would look like. And so what that would mean then is if I took If I took that now, the one thing I grabbed is the one thing that didn't come. And I translated that whole picture across this space, three-dimensional graph. If I took that whole picture and translated it across there, I would get that one. And what would the coordinates of A, B, C, D, E, F, G, H be? It'd be this would be A prime, B prime, C prime, D prime, E prime, F prime, H prime, and G prime. So that would be my image of the other one.
You didn't get better.
A, B, C, D, E, F, G, H. Did I really say HG the first time?
Yes.
Okay. Sorry, that's on film or on record too. Oh, I can't even change it. All right. Well, thanks for helping me out. GH. That's why I teach math, not language arts. When I do the alphabet, I have to do it quickly and start at the beginning. Okay? So anyway, this would be the ordered triple. Seriously? This is the ordered triple that represents, this one right here, represents A prime, and then this is the ordered triple that represents B prime, and then this is the ordered triple that represents C prime, and so on. Okay? We're kind of quick there. Oh, it's ready to publish my video now. Good. I closed out of that. It must still be running. I'm probably in trouble now. All right. Any questions on the translation? Sorry, I got distracted. No questions at all on translation. Okay. Then the next background information that you probably don't have is if I want to multiply. I want to multiply a matrix. I'm going to multiply 2, 3, negative 1, 4 by, we'll just make it simple, 1, 2, 3, negative 4, 5, negative 6. Okay? Yeah, thought they had to be the same. That's a good question. I thought they had to be the same. What are the dimensions of the first one? 2 by 2. What are the dimensions of the second one? 2 by 3. In addition, you're right. The dimensions have to be exactly the same. But in multiplication, I really don't know what they call this. Maybe Mr. Fauch knows that there's a special name for that. But I always set it up this way, and I say those two numbers have to match. Okay? And so these two must match. That's right. Then that means these two will be the dimensions. Oops, there. Dimensions of the product. Okay? So they'll be the dimensions of the product. Now when I actually teach this in Algebra 2, at least one of the problems I make simple like this, because the reality is I'm going to also show you how you can do this on your calculator, but it won't matter. The reason I'm showing you this is because the numbers we're going to be using, it's better if you understand what's happening than it is if you understand how to use your calculator. It'll be way less work. Okay? So, if I was teaching this to you in Algebra 2 for the first time, I would say you have to then draw this matrix. And you have to label those 6 locations, because we said it's going to be a 2 by 3, right? And this first location is row 1, column 1. Would you agree with that? It's row 1 and it's in column 1, right? So what would this one be? Row 1, column 2. That's correct. Willow, what would the next one be over there? Nice. Row 1, column 3. And then if we move down to here, Noah, what's this first one?
Row 1, column 1.
No, row 2, column 1. And then the next one, Kendra? Row 2, column 2. And then everybody, what's the last one? Nice. And the whole reason I tell them you have to do that and write it down is because those labels are also directions on how to get the number that goes there. It's row 1, column 1 means row 1 times column 1. Okay? And so if I do that, and this is how you would add it, you would, or times it, you'd say 2 times 1 plus 3 times negative 4. Okay? You can't see this on the video, but I always say this is two-finger multiplication. These two fingers are all I need. I'm going to take these two numbers right here, and I'm going to multiply them by these two numbers right here. And so it's 2 times 1 and 3 times negative 4. And then you add them two together to get negative 10. Okay? 2 plus negative 12 is negative 10. I agree with that. So that first element would be negative 10. All right? So then the next one. Row 1, column 2. So, Max, Fortin, I haven't picked on you yet today. Row 1. No, let's just do this again. Row 1. Pause. Column 2. Now, how would I do that, Max? What would I write here to show the teacher, hey, I know what's going on? 2-finger multiplication. 2 and 3 times 2 and 5. So 2 times index finger. 2 times 2. Yep. 2 times 2 plus pinky finger. 3 times 5. Yes. Okay? And what does that add up to? 19. 4 plus 15 is 19. Okay, Max, you try that again on the next one, please. Row 1, column 3.
2 times 3 plus 3 times negative 6.
Nice, that's correct. 2 times 3 plus 3 times negative 6. Now, is anybody else not catching on to that yet? Okay, Taylor, you'll be next. What does this add up to? 6 plus negative 18, negative 12. Okay? And then the next one. Negative 1 times 1 plus, thank you, 4 times negative 4. And that adds up to negative 17. I agree with that. Okay? Garrett, you haven't spoken yet today. What's the next one going to be? Oops, I forgot to move this. Row 2, column 2 now.
Negative 1 times 2 plus 4 times
That's a positive. So negative 1 times 2 plus 4 times 5. So it's negative 2 plus 20 is that 18? And then the last one, Courtney, you knew this from the beginning. You go ahead and tell us.
It's negative 1 times 3 and 4 times negative 6 get negative 27.
27 24, negative 24 and negative 3 is negative 27. I agree with that. Okay? That's how we do it. All right? Now, how are we going to use that? Well, we're going to take and reflect. Okay? We're going to reflect pictures like that last one I did over one of the planes. Okay? So let me pause just. The first couple problems are just identifying the vertices to our figure. And so like we did, the first thing we did with the 3D picture, we had everybody take turns giving us the ordered pairs, and then writing it in matrix form. And then we had one or two that's translating, and then you're going to have one or two that's like this. There's only like 6 problems in the assignment. Okay? So here we have our three-dimensional axes. And if I just draw, let me try to draw a little better. Wow. I'm not recording. Oh, I am recording. Wish I wasn't recording all that. Yeah, not too bad. Okay, so my picture looks like this. All right. Now, if I want to reflect that over the YZ plane, okay, this is hard to show in the video, but we'll try. In this plane right here, okay, if I were to reflect that over that plane or through that plane, no. How come when I don't want them to stick together, they do? I do want them to, they won't. So if I move that whole thing over the plane, okay, I would get it there, right? I would get that picture, okay? And if I trace that, it's going to move my dots too, isn't it? Oh, come on. Oh, well. I want them to go together, so. Anyway, my blue figure then would look like this. And it would be there. Okay? So if I reflected over the I'm sorry, I said wrong. Over the YZ plane, I would get that blue box, wouldn't I? If I reflected this over the XZ plane, this plane here, okay? If I reflected that over that plane, I would get this box, wouldn't I? And so it would look like this. Oh, we don't need that very much. And I would get this picture. Okay? I forgot a dot. But anyway, I'd get something that looked like that, wouldn't I? Yeah, and that just shows how bad my picture was on my links. These two actually should be the same dot. But no. And so it looks something like that. Okay, not exact, but looks something like that. And so that's what I get there. Now, this was the x z plane. This one over here was the y z plane. And so what plane is left if I want to reflect over? The xy plane, which is this plane here, right? That would be my xy plane. So if I want to reflect over that, then I'm going to move this. Yeah, let's move that out of there. I'm going to move this down there. Okay? And I would get that box. Okay? And so these three matrices right here are what we would use to find the coordinates of those points without actually showing all of that reflection. Okay? And so if I want to reflect over the xz plane, I would multiply my matrix by this matrix. If I want to reflect over the yz plane, then I would multiply by this matrix. If I want to reflect over the xy plane, I'd multiply by this matrix. Okay? Those matrices that I gave you the first thing in notes are what we will use then to multiply. Remember row 1, column 1, row 2, column 2, row 3, column 3? Okay? Let's go back. Go back to here. Let's create a bunch of space so we can use this page. And let's actually move this back to where it was. Okay. And let's say it's a cube, and all three sides are 3. So this would be 0, 3, 0. This one here would be 3, 0, 0. And this in here would be 0, 0, 3. Right? And if we labeled them A, B, C, D, E, F, G, H. Okay? And so we would have A is 3, 0, 3, right? You agree with that? 3 out, 0 left and right, and 3 up. 3, 0, 3. Okay? What's B? Oh, we already said that. That's 3, 0, 0. What's C going to be? 3, 3, what'd you say? 3, 3, 0, that's correct. Out 3, right 3, and not up and down at all. So 3, 3, 0. And then D? D is actually out here. It's 3, 3, 3. And then E, now that's back on the axis. So that one's 0, 0, 3. And that's, to be honest, number 9 I might need to help you with just because it's really hard to see what they're trying to show us. There's one point they didn't give us, and it's really hard to see where that is. And so we may need a little help on identifying the coordinates to I said C, but it might have been D. Point D on the number 9. We just did E, so where's F is over here. So what's that? Nice. 0, 3, 3, and G is down here. 0, 3, 0. And then 0 what? 0, 0. Nice. Okay? Now, the dimensions of that are 3 by 8. So when I multiply that by a matrix, it's got to be something by it's gotta be something by 3, right?
It's gonna be a three
Which
by
is the
three.
ones they give us.
What? Yeah, it's going to be a 3 by 3, but I say to just multiply, it has to be a something by 3, right? Those 3's here have to match, but it could be a 7 by 3 and I'd end up with a 7 by 8, right? In this case, it's a 3 by 3. And which axes did we say we want to reflect over? The XY axis, the XY plane, I mean. The XY plane. And so my matrix for the XY plane is -1. No, I'm sorry.
It's 1, 0, 0,
Yeah.
and then 0, 0, and 0, 0.
And XY, so 0, 1, 0, and then 0, 0, -1. Am I right?
Yep.
Okay. This is how I remember it. Which letter's missing? And that's the one that has to have the other sign. The others are going to be 1s, and that's going to be a -1. Okay? Now, I don't want to go through that whole process again with rows and columns, but I want you to look at what's happening. We said our result has to be a 3 by 3, 3 by 8. Thank you for helping me. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay? And we could identify each one of them. Row 1, column 1, row 1, column 2, row 1, column 3, right? And so that means then row 1 times column 1. I'm just going to do this once because I want you to see what's happening. And then from there, I think you'll understand what's happening on every one of them. This is 1 times 3 plus 0 times 0 plus 0 times 3. What happens to the last 2?
There's zeros.
They're zeros because of these 2, right?
So for the first 4, they're all 3.
And then the next 4, what are they?
0.
Okay. In fact, all that's really happening is I'm multiplying all of this by what? By 1. That's right. Because of the placement of the 1 and these zeros, I'm multiplying this entire matrix by this row. I really end up with multiplying all of this by 1. And so I really just get 3. And what's this one going to be? 3 and 3 and 3 and 0 and 0 and 0 and 0. Now when I do the second row, it's 0 times 0 plus 1 times, I'm sorry, yes, I looked at the picture wrong. 0 times 3, this column, and then 1 times 0 plus 0 times 3. And so because of the placement of these zeros here, what's happening to this row and this row when I multiply?
Zeros.
It's becoming 0. And what's happening to this row because of that 1?
0.
It's
Multiply by
this
1.
row.
Multiply by 1.
Yeah, it's going to be multiplied by 1. And so I end up with,
Copy the same matrix.
ow, come on. I end up with the exact same one, 0, 0, 3, 3, 0, 3, 3, 0. Okay? And then what do you think is going to happen to that third row?
Copy the same matrix down. But positive numbers become negative. And negative numbers become positive.
That's right. We're going to multiply. The result is everything's going to cancel except the bottom row is going to be multiplied by a -1. And so I get -3,
0, 0.
0, 0,
Negative 3,
-3, -3, -3,
0, 0.
0, 0. Okay? So, if I was to go come back to this in just a second. Let's say I had this matrix. What would happen in that one?
Negative row would be on the top.
The top row, all the x's would be changed to negatives, or I should say the opposite sign, right? Because if they were negative, they become positive. If they're positive, they become negative. And the rest of the rows would stay the same, wouldn't they? Okay? And so if I go XZ plane, it's the middle row that's going to be changed to the opposite sign, and the other rows will stay the same. All right? Now, I don't expect you to show each of the multiplications like we did in that base work that led up to this, okay? I want you to take advantage of your understanding of these matrices. But you have to remember which one goes with what, so you can match them up properly, okay? Our assignment today was 7 through 17 odds, I believe it was. I guess let's look. We'll double check here. Yeah, 7 through 17 odds. And tomorrow's get caught back up day. Make sure everything's done. If I have time today, I'll copy off your practice test and have it ready for you tomorrow. And have our sub now is Miss Johnson, who did some contact. No, she did student teaching with me a long time ago, 2 years ago. Yeah, she's blonde. But anyway, she'll be in, and she's a math and Spanish. I'm not sure which one's major, maybe they're both majors, I don't know. But anyway, she has a good math background. She'll be able to help you with this. Okay? Any questions?